Hi again. For this clip, I will explain how I actually made the exponential growth bias educational video. To begin, I will load the starting scene that we used. And I think when you see me work through the process, you will have a better idea of how you can use our tools. So let's begin. You may recall that you can create scenes with our little application that we call Melablocks. So just like in the PowerPoint slides, you might have like a title slide. You might, create something like this for your title slide. And you create the cubes by clicking create on the HUD, and you have access to many different types of objects. In this case, I used text blocks, and I've colored the background and the foreground of the text. So this is the title of the presentation, that was recorded recently, and the title is Exponential Growth Bias. And what I've done is, at least that's my style of presenting, people might choose to do otherwise. I tried to collect ideas that I would refer to and just stick them to, to places where I think they would be more easily accessible when I need them. Okay. So for this clip, I wanted to, my motivation was to explain what exponential growth was in the traditional way, just by mentioning the equation and, trying to describe it in ways that you would traditionally do in a classroom. But here, I have been trying to make use of the opportunities that 3D virtual worlds provide. Okay, so that's why I thought that in addition to explaining exponential growth functions, I would also instantiate an example that people can visit, can see, so that the concepts become clearer. And I needed a setting for the problem. Okay. In order to do that, I created a small house. And if you remember, the problem was about placing blocks on a 4x4 meter square area. Okay, so that's what we were doing. So this was the simple house, and we had a floor space inside, which was the 4 meter square floor space. I wanted to give an idea of how much space there was inside this area, to give to express how tiny this space can be, can feel like. I think the 3D representation is useful. Okay, because the student will be able to see, okay, this is the height of the rafter, and this is the size of the room, and if they look at the grid, they will see that it's actually a 4x4 grid. And if I tell them, the problem statement, which is to stack cubes on these squares in a particular way. The first square has one cube, the second one has twice that number, etc. And having it anchored in a 3D visual representation like this that they can immerse themselves in might be more engaging to a class of students. So once you have the setting of the problem, then you need to remove the superfluous things and try to focus on, to further simplify the situation. So in order to do this, I used like a little trick, okay? So let me load, not this. I actually loaded 2 grids for this initial setup, but when I do the filming, I would only film one grid on the right for obvious reasons, because I intend to show progress through the experiment, through the demonstration. And one way for me to do this was to make sure that everything I need is already created. Everything I need is already raised here. Okay? And if I pick the frames I need, I would click on rearrange, which basically means rearrange these objects to what you need. So one of the first frames I needed was this. Remember, we removed the house and I needed to be able to show how I would stack the cubes inside that 4-meter square space. Okay, so that's simple. And then as I continue to explain, I would just load the next frame. Okay, so I think I loaded the second one, so maybe this is slide 3, hopefully. Yeah. And then I explain the abstraction, what I intend to do, how to make all these cubes fit. Okay, so that's why I said, okay, we can create an abstraction. Let's call it like this black cube that represents 16 white cubes. If we go to the next one, we have the second set of cubes that are placed. All right, I also decided that it would be helpful to have some kind of annotation here so that people know that every white cube represents 1 and every black cube represents 16 white cubes. So I keep on going through this process. Was it 5? Okay. So you have the next step is here again. We are creating this brown cube and the other stack. And I think I should have mentioned how I create these frames. Basically, I have an initial setup where I have everything I need, and then I just select and move these objects to this area here. And you remember, how to select. So I would, if I long click, if I left click and hold until the object lights up, I can, just move it. So let's keep on loading the other remaining 6. This one is, let's jump to 7. And finally, we are going to load the last frame. And this basically brings up, the complete solution. And this is supposed to illustrate all the cubes that fits in this space. All right. So the student will be able to have an idea of not only how these cubes actually fit in the space, but they will have an idea of what kind of compressions we made so that this representation fits within the constraints that we have. And then I tried to refer to real world landmarks in order to explain the meaning of 65,535 meters. And then, of course, I introduced an extension to the problem. I said, what will happen if instead of a 4 by 4 meter room, we had like a 5 by 5 meter room, and we had to do the same exercise. And then we had to take all these cubes and stack them one on top of each other. And we had to find the height produced, how high this column would be. And turns out it's even, larger than, the radius of Earth by a lot. Okay. So, what does this experiment show? It shows, firstly, that when you are creating like an educational video and you are explaining a concept that is not so trivial, as in this case, which is the exponential growth bias, you want to try and make sure that your student understands the bias part. Okay, that is, why is it that people tend to underestimate the values of y in a function y is equal to a b power x, that I described in my previous video for b greater than 1 and for a greater than 0. So basically, I think that our main goal has always been to shift the conversation from the mechanics, the development issues of 3D worlds, the usability issues, and really focus on the educational content. So I think I will conclude this how-to video here, and hope that you got some idea of how I actually made the previous video clip. Thanks for your attention.